Okay, so rather than trying to type something up, I thought a video might be a little bit easier, and I used Excel here. I just basically made up some numbers, like a similar scenario to what Carole was describing to me. So let's just suppose, I'm just making this up, suppose for my AP Stats kids, I give them a practice exam every year, and then what I like to do is compare their practice exam score to their actual exam score, right? So the idea would be like a pre-test, post-test, are these differences measurably different? Are they significantly different, right? Luckily, I think, so then suppose I did that in 2018, and then suppose in 2019, I used a new software package to review for the exam with students, and I want to see, maybe their actual score has always been higher than their practice score, right? But is 2019's difference in actual versus practice better than 2018's? It sounds like you're trying to do something along the lines of that analysis. Now, Excel is not the software of choice to do statistics for me, but fortunately it actually does both of these tests under the data analysis. So you probably, if you're using Excel in your class, they probably definitely told you to download the analysis tool pack. If not, that's an easy thing. I actually made a video for that for my college students. But anyway, to get to the heart of this, so the first two tests would just be one sample t-test, and I would imagine what you're trying to show is that the post-test scores are significantly higher than the pre-test scores, right? So the way that works, if I use Excel, I would just do equals, and then I'd come over to the actual score, and I want to subtract the practice score from that, or post-test minus practice. Press enter, and then I can actually just paste that formula or copy that formula all the way down. It's a little drag, okay? So then these are all my paired differences. So the idea would be, if I do equals down here, try to give it an average. So this average difference of 0.89, I would want to do a one sample t-test, okay, to see if it's significantly greater than 0. All right, if that's what it is that you're trying to do, to see that the post-test was significantly higher than the pre-test. And then obviously I could do the same thing over here. Equals post-test minus pre-test. Boom. And I'm going to drag this down. Okay. And then I would find this sample mean of these differences. And I'd want to see, is this significantly different than 0? Okay? So that's two separate one sample t-tests that just show, like, all right, look, kids do better on the actual exam than they do on the practice exam. So that's, that's why we practice, they get better, so on. Now the second layer to it is, did the folks in 2019, like this difference, 1.3, is definitely bigger than 0.9, right? But the question is it significantly different? So for that, we would do a two sample t-test, okay? Two sample. The one tail, if it's two-tailed, you're just trying to see if they're different from each other. But if I specifically want to show that they did better in 2019 than they did in 2018, then it's a one-tailed test, right? It's a right-tailed test. Now, I think Excel does both of these tests for you, right? And I don't even have to do these differences here. All right, I'm going to show you what I mean. So if I come over here, if I go up to my data analysis tab and slide down, the first test I did was t-test paired to sample for means. All right, that was the first. I didn't actually do the test, but I found the differences, and then I would run a t-test against 0. Like I said, Excel doesn't have, unless you have the pH-stat add-in, which is actually really good. Basically, you just need the mean and standard deviation and sample size, and you can run it. You can do it on a graphing calculator. But I'm going to do t-test paired to sample for mean. So let's click on that and see what it gives me. So what's my first variable? This is the paired differences test. Is the 2018. The second variable is 2018 actual. And I do have labels in that first row. The hypothesized mean difference would be 0. We want to see if it's significantly different than 0. And then your significance level, whatever you want that to be, I'll leave it at 0.05. You can make it 0.01. Let's see what they give us when I click OK on that. It didn't give me an option of a one-tailed or two-tailed test, so maybe they give us everything. Up there. Okay, so here's my result, right? So they took two separate means, but they should have done the paired differences, right? I don't know why they did two separate means. It's really not two separate means. It's just the one mean. That's why I'm looking for that one sample mean that I had. I'm looking for this guy, 0.89 somewhere in that printout. Doesn't look right. So I don't know if this did this the way that I would want it to here on Excel, but I can check. I'll check it on my graphing calculator just to be sure. This doesn't look right to me, so I don't like really to use Excel for t-test. But so that we'd want to do a one sample t-test for those two. And I'm not 100% sure if Excel did that the way I wanted to, but so that would be that. This other test that we would do would be a two sample t-test comparing these two guys, right? So let's see how that works out if I go, if I don't want to pair them, if I want to keep them separate. So I don't ever assume the variances are equal. I'll assume that they are unequal. Okay, so now my variable range 1 would be the differences, would be these guys. All right, are these differences significantly different from these differences? Okay, and I do have labels there. Okay, and then we would analyze what we have here. Blow that up a little bit. Of course, it doesn't cooperate. Yeah. Okay, so the one mean was 0.89, the other mean was 1.3. Both we would test those again individually, so they're significantly different than 0. So when I look at the one-tail test, I get a p-value of 0.11. So what that means to me, if the significance level is 0.05, it means it's not unusual. It means that I don't really have a significant difference between those paired differences. On an individual basis, when I looked at them individually, those individual t-tests, they might be significantly different from 0. Like, in other words, this might be significant, like the difference between the actual and the practice. This could be significant for 2018, and this also could be significant for 2019, but it may not be significantly different. These two might not be significantly different. Okay, so hopefully that helps. Disregard this t-test. I do not think that Excel did that the way that I would have wanted it to. Let me try it one more time and do it as the paired differences. So t-test paired two sample for means. Yeah, see, it gives me two lists, so I'm thinking it's going to find these differences and average them, but that output does not look like what I'm looking for there. Alright, so I'll stop the video here. If I can, I could run this on the graphing calculator, at least the matched pairs, so you can see what I mean. It looks like Excel did the t-test for the difference between these two perfectly fine. That seemed okay to me, the way that came out. And my conclusion would be on this sheet. My conclusion here would be that they're not significantly different. Notice with the two-tailed test, the p-value is double that, right? So this is one where I'm specifically trying to say one is definitely higher than the other, and I don't have significant evidence of that. This one, where it's two-tailed, is just trying to see if there's any difference. This p-value is always double it, because the result could fall either below the mean or it could fall above it, so that sort of probability area gets doubled, right? If the area in one tail is 11%, like a difference like this, if these guys aren't really significantly different, then a difference like this one happens about 11% of the time, okay? But then we'd say, well, it could happen in one way or the other, like these two could switch. This could be 1.33, this could be 0.89. and that would be the other way, so that's why that's double, 22%. Alright, I'll stop this video here, and I'll see if I can get you a graphing calculator one as well.